Metabiota.
Excellent. Thank you very much. I'd like to thank the committee for inviting me here today to talk about the Global Virome project. A couple of months ago, I was at BCCDC and discussed this project with a few of the people here in the audience today. And everybody so far has had excellent projects and good data and everything else. I don't really have data. It's more of an idea. And I'm going to try and leave some time at the end, even though we're going into lunch, to really try and get some questions from you guys to find out if you're interested in the project, how your different ministries or departments or whatever could help out. So I'm a scientist with Metabiota. I'm an epidemiologist. We're a company based out of San Francisco. We specialize in epidemic risk, disease surveillance, and that sort of thing. And for reasons that are sort of beyond me, we have an office in Nanaimo. So luckily, I'm able to be based there. So I'm here as an employee, but also as a Canadian scientist, because what I'm talking about is going to be, it's a global program, but what I want to do is get it started here in Canada. So, for starters, the end of the pandemic era, I know is very lofty sounding, but you kind of stay with me. So, right now we have a bit of a problem. I think as most people in this room will notice, in the last couple of decades, we've been getting more and more emerging infectious diseases. And these are not small ones, they're large ones that are real issues. And they're becoming more prevalent and they're coming up more often. And I think what's becoming very obvious to people like us, and now even to the more lay community, if you will, is that we're not ready for when these things happen. Whether it's SARS, MERS, Ebola, Zika, chikungunya, whatever it is, when these things come out, we're not ready for them, even though in a lot of cases we already know them. Ebola, I mean, it's been around for decades and decades, but when it hits, we're still not ready. Zika, it's been around for a long time as well. When it comes down to South America, we're still not prepared. And we can do a lot of things. We can put money into infrastructure in underdeveloped areas. We can increase surveillance. And those things are all good things. We should be doing them. But there's also more we can do on top of that. I kind of just spoke about this. In the last few years, it's more and more often, and it's becoming almost commonplace that every few months there's an outbreak of this or that somewhere, and it's the same thing. How come we didn't see it before? What can we be doing that we're not doing already to stop these things from happening in the first place? Or, when they do happen, to catch them quickly and to diagnose the problem and to fix it before they get too large. So, we know that we want to do this. We know we have a problem, but how can we do it? Like I said, we can increase infrastructure. We can put more money into aid, surveillance, and that kind of thing. What I want to talk about is something a little bit different. It's different than what we've been doing already. We already spend money on aid. We already spend money on surveillance. And I'm certainly not saying we should stop doing that, because we absolutely need those things. But what I think we need at this point in time is to start thinking a little bit differently about the scale of the problem and the scale of the effort that's required to solve this problem. So there's outbreaks of all different kinds. I'm specifically interested in viral outbreaks, and the program, the Global Virome project, is interested in viral infections. And as we know, there's hundreds and hundreds of thousands of viruses in the world, millions. We hardly know any of them. It's nearly impossible to culture them. And when you go to do something like whole genome sequencing, whatever else it might be, there's so much we still don't know about all of these viruses. It's really hard to get at what it is we're looking at and what's causing a problem. So we need to turn the world of these unknown viruses into something that we know nothing about, or very little about, into something we know a lot about, or as much as we possibly can. So the solution to this problem is a lot of work, clearly. It's not something that happens overnight, but what we want to do is turn the discipline of emerging viral diseases, emerging infections, whatever you want to call it, into something that's happening now on smaller levels, individual outbreaks, packets of research over here, packets of research over there. We want to take those small things and we want to really scale them up. And we're talking big, global. We want to turn those little projects, or things that may seem large now, we want to make them look little. We want to make this a huge project, turn it into a big data type of a project. So the Global Virome project is intended to transform the way we think about emerging diseases, the way we think about zoonotic infections and viruses. The goal, in as few words as possible, is to discover and sequence and catalog virtually all of the world's potentially zoonotic viruses. So this is a huge deal. It's something that's not easy. We've been working for a really long time up to this point to get as far as we have. And we've been doing really well in some areas not as much, because either it's extremely difficult to do the work, it's expensive. A lot of the viruses that we want to be working on are coming from areas where it's really difficult to work. But the end goal of this program is to identify and characterize as many as possible, essentially all, of potentially zoonotic diseases or viruses that exist in nature. And as I said, doing this is going to turn the world of virology, the world of sequencing, emerging infectious disease, from something that is right now relatively low volume into something that's huge. And I know virology and sequencing really does, it creates a lot of data, gigabytes, terabytes of data, depending on what you're sequencing. We're talking about taking this really to the next level, something that's so much larger that right now we essentially can't do because we haven't been. And so we're sort of starting from the ground up on this type of a project. So the idea would be, these viruses aren't going to present themselves to us. We have to go look for them. So we're talking about, on a global scale, doing an awful lot of sampling. Whether it's, mostly we're going to be focusing on avian and wildlife. So there's still, of course, that leaves out humans, livestock, that kind of thing. But what we're talking about here, at least at this stage, is wildlife and avian. So we want to do a ton of sampling. And anytime we sample, we want to know what animal that sample came from, where was it, what was the ecology around, what's its epidemiology, were there symptoms in this animal? And then that's just step one. Step two would be to find out what's living inside the animal. It doesn't need to be symptomatic to take a sample. We want to get as much as we can. So we want to find out all of the viruses that are in there. So we're talking about deep sequencing, and then eventually, after that, once things are identified, whole genome sequencing. And I'm not going to pretend to be an expert in that area. There's people here who are much more versed in these topics. But the idea is, instead of going in and looking for one thing, say a family of viruses or one specific virus that we know causes problems, we want to take a sample and we want to look for everything that's in it. And once we have this information, the ecological, epidemiological, and viral information, we're going to put it all together. This is a global program, so we want to take these samples from all over the world and put it all together in one database where everybody has access to it, where scientists can go, look at it, work on it, share it, and without having restrictions on whose data is this, what country did it come from, who has access, who doesn't. Everything should be together so that we all have access to look at this data and to do something with it. So something like this should, ideally, have a really large impact on a bunch of different things. One example we like to talk about is the way we create vaccines. So now, typically we like to create vaccines based on an individual virus. We're pretty good at that in a lot of ways. Some things are a little bit beyond our reach now because of mutations or whatever it might be. But just think of the options available. Instead of creating a vaccine for MERS or for SARS, what happens when you have thousands and thousands, tens of thousands of different coronaviruses? You can really look at across all of that variation and think of a new way of creating these vaccines. They don't specifically target one species or one subspecies. Whole families or genus, whatever might happen. But we're talking about creating vaccines now for huge numbers of viruses rather than one or two at a time. When we have all of this data, we're going to be able to start thinking about ways of preventing these epidemics and pandemics from happening in the first place. We're going to know what viruses are out there, what they live in, what they like to infect, what they make sick, what they don't, how are they shared between different animals that live in the same area, How are they transferred to people? What do the contacts look like? And when we have all of this information, we're able to be much, much better at preventing these things from happening in the first place. Predicting is probably a long way off at this stage in the game, but it's not impossible, I would say. We might not do it in the next couple of decades, but we're working towards that. And I think the central theme of so many projects, the last few lines of every paper is more research is needed, more data is needed. And that's the idea of a program like this, to get that more data, to get as much as we can possibly get, to the point where you almost right now don't even know what to do with it all. And think about frontline medicine. How difficult can it be when somebody comes into the doctor's office, whether it's a human or an animal, to diagnose what's making this person or this animal sick? We have really such a small library of viruses to choose from in the grand scheme of things to kind of point out what it is that's making this person or animal sick. When that library grows to hundreds and hundreds of thousands of viruses, it's going to make it a lot easier to pinpoint what's causing the problem and how we can solve it. On top of that, just doing a program like this that's truly global and extremely large, and pushing the boundaries of what genomics and sequencing is and what virology is and emerging infectious disease, what the definitions of those things are, will ultimately create new opportunities that really right now we can't even foresee. Think of the Human Genome Project. When that was started, it was a similar idea, something huge that we've never done before. And there's a lot of people thinking, is it even possible given the technology that we have right now? It took a long time, and along the way, huge steps were made in the way the sequencing was done at the beginning of the program and at the end. And it didn't happen in isolation. It happened because huge numbers of researchers were all working on the same thing, pushing forward the technology. And I think we can expect to see the same thing in a GVP program. So many people working together on the same thing, pushing the boundaries, will inevitably create new technologies that will make what we're looking at today, the things that we use today, seem antique in another decade or something. And not only that, but we speak mostly about these outbreaks and infectious disease and that sort of thing. But as we know, there's lots of different viruses that cause chronic problems, cancers, and that kind of thing. So not only will we be grabbing this information about zoonotic data and how it impacts infectious disease, but hundreds and hundreds of thousands of viruses, we're going to be able to start connecting the dots on infections related to viruses and those chronic diseases as well. So what this will give us is a snapshot in time, essentially somewhere to start from. Right now, our snapshot is extremely small. We don't really know what's out there. We're really good at finding some things that we know about and that cause problems for us, but we don't know what's the next thing. And when we have this huge global snapshot of all the viruses that exist and what their potential impacts are, this is going to make going forward, deciding the road to take next, much easier. Well, depending on how you look at it, you'll have an awful lot of options available, I think. And not only that, so I work right now in a program called Predict, and a lot of the work that we do is in a way similar to GVP, and we try and create capacity in a lot of low resource areas. And since GVP is going to be global, it will take a lot of capacity building, like I was talking about earlier. And even somewhere like Canada, we have some of the best labs in the world, but to do a program like this, more capacity will be needed. And after the program eventually ends, all that capacity will still be there, whether it's technology, whether it's staffing, training, whatever it might be. These will have lasting impacts beyond just the program itself. So I sort of described the approach already. I'm getting a bit ahead of myself, but that's okay. A ton of samples. What we really need to do is look everywhere. What's out there and just find as much as we possibly can. As I said, we're sort of interested in two groups. There's the wildlife. What I mean when I say wildlife is essentially three different taxa: rodents, bats, and non-human primates. Various studies and models have shown that really these three taxa are the ones that are most likely to harbor viruses that are going to spill over into humans or have the potential to do so. It doesn't mean we're not interested in all of those other taxa. It just means that at least getting started, these will be the priority. And you can see on the right-hand side, the areas in the world where those types of animals live. We don't have very many non-human primates in Canada, but we have a ton of bats and we have a ton of rodents, just as we just heard. But what we also have in abundance is avian. We have tons of waterfowl and wild birds. And as we know, all of the, many of the flu viruses originate in these avian species. And so Canada is in a really good spot to really contribute significantly in that section of the program. GVP can almost be considered the follow-up to a huge pilot project. I work for the Predict program. It's in the second phase of the program. First was 5 years, this is 5 years. We're just going into the fourth year now. So this is a 10-year, essentially, pilot program worth, I don't know, $250 million or something like that, which is a really big pilot program. But what it has taught us is that we can do this. We work in really difficult areas, 31 countries around the world. We used to work in the first iteration of the program also in Latin and South America, but for financial reasons had to kind of focus. We work in 31 countries across Africa and Asia, and some of the most difficult places to work in the world with extremely low resources. But what we've seen is you can do it. Right now, our sampling scheme is viral level investigations for 5 or 6 or 7 different viral families that we think are sort of the most dangerous or problematic right now. But what it's given us the confidence to say is that a truly global version of this on a much larger scale is possible, and the amount of effort required isn't so much that it can't be done. Oh, 5 minutes. So I'll go past that. What are the opportunities here? So as I said, I work for a company based out of San Francisco. A lot of the people who are on the board of GVP, sort of trying to get this thing rolling, are Americans. But as I said, this is a global project, and I'm really here as a Canadian scientist. What I want to do is take the Global Virome project and get it started in Canada. There are a lot of really good reasons for Canada to get involved in this. For one, we have some of the most talented scientists and best labs in the world. So we've already got a head start over a lot of the countries that we already work in, and we can really be a leader in how this program moves and how it grows and how it's run. On top of that, we have a lot of biological diversity. So not only supporting the program intellectually, but with all of the samples and everything else that we're going to need to move this program forward. So we're in a really good place to do that right now. As I mentioned, we've already been having conversations with BCCDC, SFU, and some other groups about what this could look like in Canada. And one thing that we've already been considering is, think about all of the data that's going to be generated. It's really mind-blowing how much information a program like this is going to create. And you can't just load that on an Excel sheet and hope that you're going to be okay. So we know through the Predict program already, we have a database called Edith that we house out of Nanaimo. It's quite large already and quite sophisticated, but we need something a lot larger. And we know that folks at BCCDC and SFU and all that, all of the partners involved are really good at this type of thing, handling genomic data, epidemiological information. And so we're already talking about how can Canada provide the central pillar to hold up this global program. So if you don't have a place to put the data and you can't get it and you can't use it, it's useless. So one good way for Canada to really get involved right off the bat is to create that core so that all of the other countries can start working on this program. Quick snapshot of some of the organizations that are already involved in this. There's no need to go through them all. As I said, this is an idea. The program is officially being launched in January in Bangkok. What I want most of all is to hear from people here, different ministries, and tell me how you think this could relate to the work you're already doing. What can you contribute? How can GVP help your program? How could your program help GVP? I think this can be an excellent opportunity, not just for Canada, but for the entire world to get ahead for once on the next big thing that could be coming. Thanks.
Great, thank you. I think we have a few minutes before questions, and then certainly we can carry on some discussions over lunchtime as well. Have you got a question over there? Any down there? I'll start with you.
Thank you. Thank you very much for coming and presenting these ideas. It's an excellent idea. But I know that in California, you may know that Dr. Rishi's lab, he's doing this kind of project with virus only, not other thing. But my question that, yeah, we can provide the samples, but then there's so many questions around it. So how I'll send you the sample, and where you'll get the money, and what the data will be stored, and how it will be used, who will be using it. It's kind of like big thought. So I don't know how all things will be shaping together. And then that is, I'm only talking about Canada, but then if you multiply with the other countries, so you can see the magnitude. So can you shed us some light on that?
Yeah, certainly. And you're exactly right. Usually the questions are, how are we going to do something like that, and who's going to pay for it? For one, yeah, it's not going to be a cheap program. Estimates for the entire world for about a 10-year program is something around $3 billion. When you consider how many countries are going to be involved over how many years, you know, it's actually sort of feasible if a country and a government is really interested in this. How are we going to do it? Good question. So the program I'm working for now, we've covered a lot of these issues already. In some of the most difficult places to work in the world, and in the traditionally extremely closed-off governments of the world, we've been successful at generating data, sharing data, getting it out of the country, of course still including all of the host countries in every step of the way. So there are huge hurdles to get over, but what the PREDICT program has shown us in these, so far, 8 years, is that it's doable. And in Canada, you know, it's almost like working in 13 small little countries in one country, right? You know, just sharing samples across borders and of provinces and that sort of thing. But it is doable, and there are networks already that we can leverage. You know, get a little bit of extra funding for for existing pathways of sharing samples and sharing data, and increase those. We could create new ones. So certainly, you're exactly right. There are a lot of things in the way, but I think each one of those things is doable in the end and is well worth the effort.
Question over here? That was the question. Okay. Are there any other questions?
Has there been any thoughts on compiling the already existing data and then just building upon that as we go to start a database like now?
Yeah, certainly. So the EDITH database that we have right now does contain an awful lot of genomic information, and you're right, there's no sense in starting from zero. So we would want to build this GVP program or database on what we already have. You know, we spend a lot of money and a lot of time creating that information already, so certainly it's going to be brought in. And we can do that, so that's on a global level, if you will. We can also do that at the country level. We know lots of labs across Canada have a ton of information already. There's often problems getting access to that information, you know, sharing of information and that sort of thing. But yeah, there's no reason we can't start with what we already have. And there's you know, all labs have so many samples just sitting in the freezer doing nothing, with a lot of good metadata associated with them. We can start there to build small and work our way up.
Great, thank you for that. I think at this point we'll break for lunch. Thank you very much for your very interesting presentation. I hope everyone enjoyed the morning.